Okay, let's look at the homework 4, problem number 6. Alright, so this is the Bernoulli equation. X squared times y prime plus 2xy equals 5y cubed. Alright, and we want to solve this equation, a differential equation, using this suggested substitution. Alright, so let's do that. Alright, first we're going to make it look like a Bernoulli equation by divided through by the coefficient of y prime. So in this case, x squared. All right. So you will get, I'm going to write that y prime as dy over dx. All right. And this divide this by x squared would be, so that would be plus 2x over 2 over x, and y then is equal to, right, 5 over x squared y cubed. All right, so this fits the form of Bernoulli equation, where this guy right here, this is our p of x, right, and this is our q of x, right, and this power is n right there, so n equals 3 in this case. All right, so we have this suggestion, so we're gonna let v to be y, raise it to the 1 minus 3, so it's a negative 2 power, right? So let's take the derivative of this guy and let's see what we can get. So this is going to be equal to, maybe I'm going to go here, right? So if you take the derivative, we get the dv over dx. It's supposed to look like, put negative 2 in front, y, and subtract 1 from the power, so it's negative 3. Then chain rule, we have to dy over dx. Right, keep this in mind. Right, so in order to get to dv over dx, we need to have this quantity, right, expression. Right, so we're going to turn dy over dx into dv over dx by multiply by this guy right here. All right, so I'm going to kind of go from here and just skip it over here. All right, so we're going to multiply by this quantity, negative 2y to the negative 3 power. All right, so if you do that, this times that gives you negative 2 y to the negative 3 dy over dx. All right, and a plus, all right, so you have 2 over x already, but we're going to multiply by oh sorry, maybe I should write it in the right order. Maybe I'll just do this. Negative 2y to the negative 3, but you need to multiply by 2 over x y, right? So that's this guy right here, and then this is equal to, right, negative 2y to the negative 3, right? Then you have a 5 over x squared y cubed. All right, so let's try to simplify as much as possible. All right, so you can see that here x cubed and x to the negative 3 cancel out each other. All right, and then we know that this whole thing right here, all right, this is the same thing as dv over dx. Right, Then we just have to cancel y, and this is going to be negative 2 power. Right? So let's clean it up a bit. So this is going to be equal to, right? So here dv over dx. So that's going to be our first term. Right, then let's collect the stuff that we already have. So you have a negative 2 and a 2 over x. So that will be negative 2 times 2, so 4 over x. Right, then luckily you see that this guy right here, y to the negative 2. We've seen that guy before. Y to the negative 2 is the substitution, so this is actually the same thing as v, right? So we can have a v here, right? Then this is equal to, so all the y's are gone on the right hand side, so you're going to have negative 10 over x squared, right? All right, then you can see that this is a new equation in terms of v in terms of x, and you see that if you look at this guy right here as your new p of x, and here as our new q of x, right? This guy is first order linear equation, right? Which means that you can use the integrating factor, which is going to be I is going to be equal to e to the integral negative 4 over x dx, which is going to be e to the, pull out the negative 4, and then you have a natural log of x, right? And which is going to be e to the natural log of x is x to the negative 4, right? Then use this integrating factor to find the solution of v, right? Once you find that solution, you can use this substitution equation to find the solution y, which is the solution of the original Bernoulli equation. All right, I'll let you finish that up. All right, I hope that this will get you guys going.